All right, we're going to start off with the day 9 problems. All of these problems are density problems, and we're actually going to be working one of each type. We'll be working one where we're solving density, one where we're solving for mass, and one where we're solving for volume. So we're going to start with review question number 21. It says aluminum has a density of 2.70 grams per milliliter. So we'll write that up here. 2.70 grams per milliliter. What is the volume of an aluminum block that has a mass of 55.67 kilograms? Mass equals 55.67 kilograms, and they're asking me what the volume is. You always have to watch these problems because they don't always give you units that match up, and that's the case in this problem where I have a mass in kilograms and a density in grams per milliliter. And the mass portion of those units has to match, has to be the same. So the first thing I need to do is change my mass units in kilograms to units in grams. So I'll have 1 kilogram to 1,000 grams, and kilograms will cancel, and that'll give me a mass of 55,670 grams. Okay, now that my mass units are the same, I can use my density formula. D equals M over V. I'm looking for volume, so if you want to change the letters around so that you can just solve for V, you can do that, or you can plug the numbers in this way. If you're going to change this so that the V is on the side by itself, you're going to multiply both sides by V. So that's going to give you dV equals M. And then you're going to have to divide both sides by D. And so that's going to give you V equals M over D. And then you're going to plug your numbers in this way. If you don't want to do it that way, you can plug the numbers in right where they are. And so your density is going to be 2.70 grams per milliliter. Your mass, 55,670 grams. Volume is what you're trying to find. I've got to get the V out of the denominator, so I will multiply both sides by V. So I'll have V times 2.70 grams per milliliter equals 55,670 grams. I'm going to divide both sides by 2.70 grams per milliliter. And then these two will cancel out, and that will give me a volume equal to 20,600 milliliters. You'll notice that I had two significant figures in the density measurement. I had 4 in the mass, so since I had 3 here and 4 here, we'll need 3 in the answer because that's the least amount. And so 20,600 does have 3 significant figures in it. Okay. If you had a problem working extra problem number 11, it is worked exactly like this review problem number 21 was. In both of them, you had to convert a mass in kilograms to a mass in grams. In both of them, you had to solve for volume. So if you got stuck on extra problem number 11, go back and do the exact same steps that we did in this problem, and then you should be able to solve extra problem number 11 as well. All right, now we're going to look at review problem number 22. A sample of what looks like silver has a mass of 1.7 kilograms and a volume of 0.164 liters. Notice I'm kind of writing things down as I'm reading the problem through. Is it really silver? The density of silver is 10.49 grams per milliliter. So what I want to know is the density the same as 10.49 grams per milliliter? So it kind of looks like I have all 3 of the values I need, But really what I'm trying to do is I'm going to calculate the density of this sample and then compare it to this one and see if it does indeed turn out to be the same or not. So I'm actually trying to calculate density. Once again, they've given me a mass in kilograms and the density is in grams per milliliter. And so I've got to convert so that my mass units are the same in both of those. So I've got 1.7 kilograms. I'm going to convert from kilograms to grams, where 1 kilogram is 1,000 grams. Hopefully this kind of conversion has gotten very easy for you by now. So that's going to give me 1,700 grams. You'll also notice that they gave me a volume in liters, but my density is in grams per milliliter. So I've got to change my volume measurement as well from 0.164 liters, and I've got to change that to milliliters. For every 1 liter, there's 1,000 milliliters, so that will cancel out, and that will be 164 milliliters. So now that I have everything in the right units, I can go ahead and calculate my density. Density equals mass over volume. Now in this one, the D's on this side by itself already, so there's no need to have to move your equation around at all. So your density is going to be 1,700 grams divided by 164 milliliters. The density should come out to be 1.0 times 10 to the first grams per milliliter. And you're probably going, well, Mrs. Thompson, why didn't you just write 10? Well, the issue is that I had 2 significant figures in my mass, I had 3 in my volume, so my answer has to have 2 significant figures in it. If I just write 10, 10 will only have 1 significant figure. If I write 10.0, then I've given it 3 significant figures. So in order to give it just 2 significant figures, I have to put it in scientific notation. Now, don't stop there, because the question said, is it truly silver or not? Well, you were supposed to compare this to this, and if I do compare these 2 numbers, this is 10, this is 10, and so to the proper number of significant figures, they are the same. And so the answer to the question is yes, the sample is very likely to be silver. All right, extra problem number 12 will be the third one that we work today. What is the mass of a silicon block that has a volume of 0.45 liters? Volume equals 0.45 liters. They're asking me for mass. And initially it looks like they didn't give me enough information, but if you look in the problem above that, that problem was also about silicon. And silicon, they told us in that problem, has a density of 2.3 grams per milliliter. Okay. Once again, my units in my volume do not match the units in my density, so I'm going to have to convert. So I have 0.45 liters. I need to convert liters to milliliters so that it matches my density units. 1 liter is 1,000 milliliters, so this cancels. And if I multiply that, I will have 450 milliliters. Okay? So now I'm looking for mass. So density equals mass over volume. If you want to rearrange the equation so that the mass is by itself, then you're going to multiply both sides by V, and that's going to give me V times D equals M. Okay, so you can plug everything into that equation. If you don't want to do it that way, then what you can do is you can just use this equation and you can plug the numbers into it. So density is 2.3 grams per milliliter. The mass is what I'm trying to find. Volume is 450 milliliters. So in order to solve for M, I have to multiply both sides by 450 milliliters. The milliliters over here will cancel out, giving me units in grams, which is what I should have for mass. 450 milliliters cancels out over there. And so then when I get done, that should give me 1.0 times 10 to the third grams. Okay, once again, I've got two significant figures here, two significant figures here, can only have two significant figures in my answer. If the answer is 10, you have to put it in scientific notation so that that 0 will be significant. So 1.0 times 10 to the 3 grams. And that will take care of the problems for day number 9.